All right, now we're moving on to the last three examples where we are showing you how you can use congruence and equals and how to kind of navigate those two different things. So the next one we're gonna do is a proof we did before. We've done ones like this a lot where we say A and B are complementary, B and C are complementary, and we know that the measure of angle A equals the measure of angle C. So, or I'm sorry, we don't know that. We want to prove that the measure of angle A equals the measure of angle C. And we know that has to be true because if these add to 90 and these add to 90, and angle B is in both of those, then A and C have to be that same number that's remaining when you subtract out angle B. So that's kind of the procedure we went through. So we said that A plus B equals 90, B plus C equals 90. We set them equal, we subtracted, and we ended up with A equals C. And you guys are really good at this kind of proof so far. Now notice the only difference here, my given looks the exact same, is that my proof looks different. Instead of proving that the measure of angle A equals the measure of angle C, I just need to prove that angle A is congruent to angle C. And now sometimes people panic and they think the whole proof changes because this is different. But if you think about it, to get that A is congruent to C, I just have to show that A is equal to C. If I can show that measure of angle A equals the measure of angle C, then it's one very quick step of definition of congruent that lets me change it over. So it's important to know, and actually it's something I forgot to have you fill in at the top, so we'll go up and do that, is when you're dealing with equations, so writing equations, substituting into equations, subtracting, adding, doing anything like that, you have to use equality or equal signs. You cannot use congruent. So like I've said a bunch of times already, you can't add or subtract congruence. So if I need to prove that the angle A is congruent to angle C, I still need to go through all the work in terms of equals because I still need to add to 90 and substitute and subtract. It's just my final answer has to be in congruence instead of equals. So instead of writing out this whole proof, all we're gonna do is pop over to this one. The only thing I would need to change is my last step. I would need to say that angle A is congruent to angle C by definition of congruent. And that's it. Even if this is confusing to you right now, because I know it's hard when I'm not there explaining it in class and you're doing it on your own. If you can get through this whole proof and this is what you get to, you're only missing one very small step. And I promise you'll get the hang of it once you get some more practice with it. All right, moving on, we have two more. The next one, number 4, says 1 and 2 are a linear pair. The measure of angle 1 equals the measure of angle 2, and we wanted to prove that the measure of angle 2 equals 90. So this is one of those ones where we know we're gonna end up dividing 180 in half because if it's split into two angles and they're both equal, we wanna divide by 2 and get 90. So we haven't done these in a few days, but what we can do is use LPP to say 1 plus 2 equals 180. We substitute because we wanna end up only with the measure of angle 2 left at the end. We wanna get rid of the ones. So I put the measure of angle 2 plus the measure of angle 2 equals 180, which gives me 2 times the measure of angle 2 equals 180. Then I divide and I get the measure of angle 2 equals 90. The only thing that's different in our second proof, actually two little things, is that first of all, I changed it so that its angle 1 is congruent to angle 2. So keeping in mind that all that means is we're gonna have to switch that over to equals before we substitute. And then I just did one other little change just to get used to that symmetric property again. I changed it so now it's 90 equals the measure of angle 2. So we're gonna have two little changes in this, okay? So my first step is gonna be the same, my given. Obviously that's not changing except for the new piece here. Now I would still start this the same way. I still need an equation that I'm going to end up substituting into and subtracting and all that stuff. So I need to use the linear pair postulate to say that the measure of angle 1 plus the measure of angle 2 equals 180. And the next thing we did in the other proof was we substituted because I don't want angle 1 to be left at the end. So I need to get something in place of here. The problem is I can't take 1 and 2 and substitute because they're in terms of equals. I need to put them, I'm sorry, they're in terms of congruence, and I need to put them into equals first. I need to change the language. So what I would need to do is take this and make it the measure of angle 1 equals the measure of angle 2. So all I did was change the way that's written, and that's definition of congruent. And now that I've done that, now I can substitute. So now I can go ahead and put the measure of angle 2 in for the measure of angle 1. So I get the measure of angle 2 plus the measure of angle 2 equals 180. And that's substitution. Now the next few steps are exactly the same as we did in the last one. So if you look over to the left, you can see we did 2 times the measure of angle 2, because I still want to show that measure of angle 2 is 90. And that's simplify or distributive, either one. Then I divide and get that the measure of angle 2 equals 90. And now the last step that's different is instead of wanting the measure of angle 2 equals 90, I want 90 equals the measure of angle 2. So I just need to flip that order. So I need to use symmetric and say 90 equals the measure of angle 2. And I am done. So the meat of that proof is the exact same. It's just this tiny little step here that we just had to change languages, and then this step here we just had to flip it over. All right, last one. This is one that we did in the, actually you guys had in practice. And in this one, I tell you that AB equals BC equals CD. And you had to prove that AD equals 3 times AB. And it's actually just like the process for the last one, except instead of dividing at the end, we just leave it in that form. So we end up with our segment addition postulate. You can still use segment addition even though it's 3 pieces. We substitute because we only want AB left at the end. So I have AB plus AB plus AB equals AD. I simplify to 3AB equals AD, and then I just have to use symmetric to flip it. The only thing that's going to be different here is, in this new example, is I changed it, so instead of it being AB equals BC equals CD, I changed it into congruence. So hopefully you're starting to see a pattern that the only thing that's going to change in my proof is that when I'm substituting numbers or these segments in, I can't substitute if it's in terms of congruence. I can only substitute if it's in terms of equals. And actually, this is my mistake. These should have little segment lines over them, and that's another indicator that you know it's in congruence. When you switch it to equals, notice how those segment lines go away. So actually, instead of rewriting this whole proof, all I want to do is kind of show you and insert an extra step that we would need. So here, I went from SAP to substituting. We would just need to insert a step here. Because if AB is congruent to BC is congruent to CD, I can't just substitute right in like I did over here. So hopefully you're thinking I would need to take one more step and say AB equals BC equals CD by definition of congruent. And once that's in terms of equals, then I would be ready to go ahead and put AB in for BC and for CD. Equals works with equals. So you can't take a congruence and sub it into an equality statement. Same thing, if I had something with congruence, I couldn't stick an equals in there because they're not compatible. So you have to do that switching first using that definition of congruent. So what I'm going to have you do for the rest of class is I have a practice packet for you that is all proofs we've done before, just with some other steps thrown in because of definition of congruent. So even on some of the examples I wrote, it's similar to this proof in this packet. So try to use those hints. So you're doing 1 to 10, and then 11 and 12 are just some extra problems to get you ready for next week, and I want to see how you do with those. And then you can check your answers before you're done. I mean, after you're done, obviously. Good luck. If you need help, just do your best, ask other classmates, and I'll answer all the questions you guys have next week.